Okay, so today we're going to talk about 5.6, the law of cosines. This is the last part of chapter 5. We talked about law of sines before, right? In law of sines, we did what? We solved triangles that were like this, and were like this, and were like this, right? These are the three that we did, right? But there are other ones that we should be able to solve, right? The other two being what? This guy and this guy, right? These two we should be able to solve. But this guy, nor this guy, we can't do by this. Can anybody tell me why I can't solve it using the law of sines?
Because you don't have the information.
Because I would have side, angle, side, right? So I'm going to know one of these each, right? There's no way I can solve for the other three. Correct? Remember when we had ASA, it was ASA, right? So they're only giving us three, but actually they're giving us the third angle too, right? So we actually end up knowing 4 of the 6. So we can use that, right? But when we do SAS, it's SAS, okay? So I have this, unknowns are here, here, and here, okay? So I can't solve for the other unknowns. And that's what makes...
Maybe on that all YouTube can see.
Okay, so you understand that? You understand why that doesn't work? So we're going to do the law of cosines to do these two types of triangles, okay? It's the same thing. Remember when we talked about solving the triangles, you're going to have to solve for what? How many things do I have to solve for? 6, right? I have to solve for A, B, C, angle A, angle B, angle C, correct? Okay? So in SSS, I am given these 3 things. Okay? It's the same thing as I had before. Remember when we did the signs, I know all the numerators and I know none of the denominators. Again, you cannot use a law of sines. Okay? But with this, what happens? So, the law of cosines, I have a squared is equal to b squared plus c squared minus 2bc cosine a. Notice that the a and the angle a are the same. Okay, there's only one angle in each of these equations, right? Angle b, length b, angle c, length c. Okay, the way I like to remember this is that a squared, the rest of the other squared added together, minus the middle term of that. 2 of them, right? And then the cosine a. Okay. So let's say I was given an SSS of 4, 5, and 20. How would I solve this? Oh, is that possible? Why is it not possible?
Because it does not greater. Yeah.
Exactly, okay? So that's the first test, right? These two added together are shorter than that, so there's no way there's going to be a triangle on this one, right? Okay? Okay, so let's say it was this, 4, 5, and 6. Now, I add these two together at 9 greater than 6, 11 is greater than 4, 10 is greater than 5, so I'm good to go, right?
Yeah.
Okay, so I am given 4, 5, and 6, right? How would I solve for angle A? Well, there's only one choice here, right? Which one has angle A? This guy right here, right? So A squared is 16 is equal to B squared, 25, C squared is 36 minus 2 times B C cosine A, right?
Yep.
61, right?
Yeah.
Move it over, I get 16 minus 61 is negative 60 cosine A. This is what? Negative 45, negative 60 cosine A. Cosine A is going to be equal to 45 over 60, right? Because the negatives cancel out. So what do I get? I get 3 over 4 cosine A. How would I solve this? Inverse, right? You have to go arc cosine, right? This is not an angle number that we know in the unit circle. If it was, great. If it was like 1/2, you would know it, right? But since we don't, it's not one of the angles that we know. You do the arc cosine. So A would be equal to the arc cosine of 3 over 4, right? The mantra. The angle which gives me this value. A is the angle which gives me this value, right? Okay? And that's how you'd find A. But you can do all the other ones, you can solve the other ones by doing that, right? So the most practical way would be to solve an A doing this, and then solve a B, and then C would be what? 180 minus A minus B, correct?
Yep.
Right? Are we good with that? Okay. So let's say that I had, so that's how you solve an SSS. Okay. So let's think about now solving an SAS. If I'm going to do an SAS, it would be, I would not give you that, and I would give you, I don't know, 45 degrees, right? Because this has to be all the other one, or it has to be the one in the middle, SAS, right? Side, angle, side, right? Side, angle, side. So how would I do this one? What can I figure out? Do I know, I would plug in B right here, right?
Yeah.
So I know this, 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 correct?
Yeah.
So what am I going to be able to find? I'm going to be able to find B, right? So I'm going to be able to find B, whatever that may be. I don't know if it's 5. It's probably not 5. Okay, but what I'm going to know this, right? But then you can go back to the SSS, which you just did, right? And you would find either A or C, whichever one, and then once you find A, 180 minus the A and the B, correct? You see the progression, the logical progression of how we're going to work this? Are we good? Okay, all right, good. So that's how you do the law of cosines. Okay, so law of cosines really is this, but there's only 2 cases you're going to use, right? SSS or SAS. If you look at the book has example 1 is SAS and example number 2 is SSS. I don't agree with that. You should solve the SSS first, because the SAS entails using the procedures that you use for SSS. Does that make sense? Just as we discussed it? Okay? All right. So I'm not going to go over the examples themselves, but that's how you would do it, okay? Let's look at example number 3. Finding the area of a regular octagon. Octagon. What happens in the octagon? Okay. So there's 8 equal sides in an octagon, right? 8 equal sides. So I'm going to draw just the one quadrant of this side. And it's going to look like this, right? Okay, on this side. So you're going to have more of them over here, right? So what is this angle over here?
45.
Huh?
45.
45, because it's octagon, right? Divided by 8, right? 360 divided by 8 is 45, right? So you get a 45 here, right? So I have SAS, right? Because they're giving us the sides as what? The radius is 9 inches. So this is 9, which means that this guy here is going to be what? 9 also, right? Because it's the radius, right? So 9, 9. So you're basically at this point, you're giving 9, 9, and 45, right? Okay, so the question is that, what are we doing? What are they asking for here? Oh, finding the area. They're finding the area. Okay, so how do you find the area here of a triangle? Go to page 444. In the middle, there is an equation there. Triangle, the area of a triangle is, area of a triangle is 1/2 BC sine A, was same as CA sine B, 1/2 AB sine C. Okay? Alright? Okay, so this is what we would use, right? So it'll be 1/2 times 9 times 9 sine of 45, right? So that would be what? One half 9, 9, 1 over root 2, sine 45, correct? And how many of these do I have? 8, because it's an octagon, right? 8. So this cancels out. I get 4 times 81 square root of 2, correct? Multiply square root of top and bottom. 2 on the bottom, 481 root 2, 2, 162 root 2, whatever that may be, that is your answer. Okay. All right, we good? All right, top of page 445. There is an equation called, or Heron's formula. Heron's formula is kind of a neat thing. If you are given an equation, or if you are given the 3 sides, lengths of the 3 sides of a triangle, what Heron's law says, and Heron's theorem says that if I call S A plus B plus C divided by 2, if I add the perimeter divided by 2, the area of that triangle is okay. Interesting formula. You'll see it here today. You'll use it in the homework, and then you'll never see it again. Okay? This does not come up again. This is the only part where you're ever going to hear about Heron's law. Okay, or Heron's formula, I'm sorry. Heron's formula. Okay? This is how it works.
Is it going to be on the test?
Yes. How's that?
Oh my god.
You said this is the only time I'm going to see it.
Oh!
Did you test?
Really?
Okay, so Heron's formula. There's a couple of example 5 and example 6 of some of the solving of the stuff. I'm not going to go over those. Those are pretty simple. So we are good with 5.6. I'm done with 5.6. Okay? So law of sines, law of cosines. We are done. Nansen?
Yeah?
Thank you.
Oh.